Okay, it's the nth root of number. So when you have a square root or just a root in general, you can write that as a fraction or you can write it with a radical. So I'll give you a moment to copy this down and then I'll explain how we read this. So for example, if you have the cube root of 8 equals 2. Because you can put any number right here. Well, I shouldn't say any number. 2, it has to be 2 or greater. So the smallest root you can take is a square root, and that's what you're used to, like the square root of 4, the square root of 9. But you can take cube roots, fourth roots, fifth roots, etc. Okay? So if you see this, the cube root of 8 equals 2. That means that's the same thing as saying, so if you rewrite it, B, this is your base, this is your power, A is your answer. So I should probably write that too. So in this example, B represents the base, N represents the root, A is your answer. So you could write this as the base is 2. So 2 to the power root, or you could say power. So 2 to the power of 3 equals 8. So would you agree with that? So 2 times 2 times 2, is that 8? So if 2 times 2 times 2 is 8, that means that the third root of 8 is 2. Okay? This can also be written in fraction form. And when you write it in fraction form, you would have your base, which is, or you would have your answer, which is 8. And you would raise that to the power of the exponent over n. And in this example, 8 has an exponent of 1. It has an invisible power of 1. So that's why we would write it as 8 to the 1/3. So this is what I want you all to realize, is that all three of these are the same thing. So the cube root of 8 is 2, because 2 to the 3rd is 8. And you can also write this as 8 to the power of 1/3 equals 2. When you take your first test next week, you will have to write things in both forms. So with a radical and with the exponent that is a fraction. So let's do another one. So if we have, let's go and let's do something a little bit more. Let's do the fourth root of 81. Does anyone know what the fourth root of 81 would be? So what number multiplied against itself 4 times is going to give you 81? So a number times the same number multiplied 4 times is 81. What number to the power of 4 is 81? 3. And if you're not sure, you can type that in your calculator. If you take 3 to the power of 4, you should get 81, which means that you could write this as 3 to the 4th. And in fraction form, it would be your base, which is 81, and that would be to the power of 1/4. That equals 3. So the main thing that I want you to realize is that all radicals and a radical, this is what a radical looks like, can be written as an exponent that's a fraction. Okay, so when you see this, what is the invisible number right here? This is called your index or your root. When you don't see a number, what is that number? What's the smallest root you can take? 2, yeah. So the smallest root you can take is what we call a square root, which is what you all are used to seeing. Okay, so we can also write this as 49 because your invisible exponent on 49 is 1. So you can write this as 49 to the power of 1/2. 49 to the power of 1/2 means you're taking the square root. And what is the square root of 49? 7. So I did a rewrite and then I simplified it. So first we're going to rewrite it and then we're simplifying it. So we're rewriting it with the fractional exponent and then we are simplifying it. So how would I rewrite number 2 with an exponent that's a fraction? 27 to the what power? Yeah, 1/3, good. So the cube root of 27 means you're taking 27 to the power of 1/3. When you type it in your calculator, you could type it in both ways. You can type it in as 27 to the power of 1/3, or you can type in the cube root of 27. What number multiplied against itself 3 times is 27? 3. All right, and for number 3, -8, I'm going to put that in parentheses. Anytime I have an exponent, we always put it in parentheses, and that would be to the power of 1/3. Now you can take, if you have an odd index, if this number here is odd, then you can take the root of a negative. So whenever this number is an odd number, we can take the root. If it was a square root of a negative, we would have to take it out because that's imaginary. Or the 4th root of a negative we would have to take it out. But the cube root or the 5th root or the 7th root, that can stay. So this just tells me that my answer is going to be negative. So what number multiplied 3 times is going to give you -8? So instead of a +2, it's going to be a -2. We do keep it negative because this is an odd number. If this is odd, we can keep it negative. If this is even, and maybe that's something you want to write in your notes, if this is even, we have to keep the negative under because you can't take the square root or the even index of a negative. But for an odd number, you can do that. If you take -2 times -2 times -2, you do get a -8. So, okay. Go ahead and copy down these 3. I didn't hear a word you say. Yeah, it's right up there by the clock, right behind the clock. No, I was about to get started. You just caught me. All right, so both of these, you see how these look very similar? But the problem is this is even, right? When it's even and it's a negative, we have to treat that differently. So let's start off with a positive. So first of all, if I rewrite this with an exponent, that's a fraction, it would be 16 to the what power? 1/4. And is there a number that I can multiply against itself 4 times to get 16? 2, yeah. But there isn't a number, first of all, well, let's go ahead and rewrite this. So put parentheses because it's a negative base. If you were to try it in your calculators, if you take -2 to the power of 4, you do not get a -16. Okay, you can't do that. So that's why we have to treat this one differently. Whenever there is a negative under an even index, we got to take it out. So what we want to do first, so this is the wrong way to do it. So now let's do it the correct way. So what you want to do is take out that -1, is you have to separate it. So you actually have to separate that fourth root of -1. So if there is a negative and it's an even index, we have to take it out. When it's a negative base, you put it in parentheses. So here, this is not imaginary. This is actually going to stay because we're talking about the fourth root of -1, not the square root. The square root of -1 is I. The fourth root of -1, we just leave alone. And then we already figured out in example 4 that the fourth root of 16 is 2. So this is how you're going to write your answer for number 5. Your answer is just going to be a 2, and then we just leave that fourth root of -1 right there. That would be my final answer. So we take out the negative. We have to leave that under the radical, and we simplify the 16. So if you have a negative underneath the radical, we have to write it as 2 questions. All right, our last one here is how do we do a variable? So when you have a variable, this is saying if I have 8 people, how many groups of 4 could I make? So when I actually teach this, I'm going to go ahead and make 8 x's too. So I have x to the power of 8, which means I have x multiplied against itself 8 times. This is how many I put in a group. So in a group, I have 4 x's. That's the group size. How many groups could I make? 2. I can make 2 groups, so it simplifies to x to the power of 2 because I can make 2 groups. And I didn't have anyone left out, so it's just x squared. So the fourth root of x to the power of 8 is simply x squared. All right, let's go ahead and start our skills check. Because I really want to see what you can do, let's just go ahead and clear off our desks. You can use a calculator and a pencil.